Hi, this is Greg, creator of the Leptos web framework for Rust. I've gotten a lot of questions about how the reactive system works. In particular, sort of two categories. Number one, how does an effect know to rerun when a signal changes? And number two, how are all these signals and things copy values in Rust so you can just move them around wherever you want in your application without having to clone things? So I thought we would just walk through a really simple implementation of a fine-grained reactive system so you can see exactly how it works and you understand what's powering the changes in your application. Let's just dive right in. So here I've got just a blank file, and we're going to start with just some really vanilla Rust WebSys WASM bindgen UI creation. I am using some Leptos helpers here, to be fair. Just to get rid of some of the noise of all of the options and results that that WebSys gives you here. But so we're just going to start with a body tag, right, which we're going to unwrap because we know it exists. And then let's just create a few elements. So we're going to create this paragraph element, and then we're going to create two buttons, which I'm going to call ink and deck. We're going to do a really simple counter example today. And so one button is going to increment the value, one is going to decrement the value, right? So for the increment, let's set its text content to +1. And dec, we're going to set the value to -1. This is the kind of stuff that you would set up using the view macro if you're actually using the Leptos framework. But this is just how you would manually create these elements. And we're going to set the text content on the P as well, and we're just going to call it not reactive yet. And then let's append these all just straight into our body, and let's put the -1 button first, then the paragraph that's going to hold the value, and then the +1 button. All right, and if I give a second to rebuild this, and I open it up in Chrome, we should see, yep, we've got our -1, not reactive yet, +1. That's great. So these don't do anything. There are no event listeners or anything. Let's add a couple of event listeners to the buttons. So let's do add event listener. And again, this is where I am using some of the wrappers from Leptos because the actual messiness of the way you do it with WASM bindgen is just going to be a distraction from what we're trying to do. So let's now just log. So when we click the decrement, we'll log -1. And when we do the increment, we'll click +1. These closures do need to take a value. We need to tell it the type. Again, this will be done by the view macro automatically. It's going to be a mouse event because it's the click event. Okay. So now when I click -1, I get a nice -1, nice +1, but obviously no values here. Okay, so let's set up reactive system, add event listeners, just so we can visually see the different parts of this. I love how the comments are green, so it kind of like sets apart different areas of the code. All right, so what do we want to do? We want to have what we usually call like CX context in Leptos or in Sycamore or in Dioxys or in whatever, where you're passing this stuff through in Rust, because we don't just use like global variables for this stuff, right? I don't know what type we want this to be yet. We'll figure that out together. All right, and then we're going to want to do something like let count equals cx.create signal 0. You'll see the syntax here will be a little bit different because it's just going to be a really, really simple example. And then we want to do create effect, and we probably want to do something like p.setTextContent some, right, count.get.toString, right? We just want to like convert this value into a string and set the text content of that p that's not reactive yet to this value. So obviously this isn't going to compile. All of this stuff is nonsense, right? But so let's start with this CX. What do we need? We need something like a scope. I'm actually going to call it a runtime. Internally in Leptos, there is a difference between scope and a runtime. There are a bunch of scopes in a single runtime. But so great. Okay, so we're going to call that a runtime. And what I really want is a static reference to a runtime. And the reason that that's what I want, we're going to implement default on this just to make our lives easier. Cool. Why do I want a static runtime? Basically, right, in Rust, this main function runs when I load the application. When the Java, we load an index.html, it loads some JavaScript to call the WASM, and then when it calls that WebAssembly function, it's going to run this main function once. So it's going to create all these things, and then it's going to drop all of them immediately when they go out of scope at the end of the main function. The only part of this that lives a long time are these event listeners, because these get converted into JavaScript functions and kind of sent over to JavaScript to handle the memory there, and attached as event listeners. So everything that's inside these callbacks, this callback needs to have a static lifetime, which means in Rust it lives for the lifetime of the whole application. And there are a couple ways we could do that. Like, we could wrap this runtime in an RC, a reference counting, a kind of garbage collection that gives us an owned RC pointer to each of the things. That's fine, we could do that. We're actually just going to leak it, right? So here I just box it and then leak it, and that gives us a static reference to the runtime. That's really important for us because now this is copy and RC is not copy. So we're going to actually stash this reference all over the place, and we want it to be a copy type. Okay, so now we've got the context, right? But we don't have create signal or create effect functions, as Rust Analyzer is very helpfully telling me. So we'll want those to be right on the runtime. And create signal is going to take, a reference to that runtime and a value, which is some t, and then it's going to return a signal t. And so obviously this needs to be generic over t, but we're not really sure how that's going to work yet. And then create effect is a really simple signature. It's in this case, let's call that static self again. It's just implements function and is static, and it's going to do something. Okay, so let's start with create signal. And first, actually, let's just flesh out the rest of the application, right? So what we want to do here, right? We've got this effect that's going to set the text content. So in these listeners, what we want to do is basically get the current value of it, and then set that to the new value. In actual Leptos, you can do something like count.update that takes a mutable reference to this. We're not going to do that in this really simple example. So that's why we're doing the separate getter and setter. And you'll see we'll run into some ref cell related issues if I try to get this inside the setter, I'm pretty sure. So we're just going to do it like this. You'll see why in a second. So this is actually -1, right? And this is +1. Cool. So that's basically going to be the whole event listener, the whole effect. This, once we've actually implemented the reactive system, this is going to power the whole thing. So we shouldn't need to write any more. If you think of this as kind of the user land code, like what you're writing in your application, this create effect is kind of the equivalent of using the view macro to do something like this, right? Where you've got a p tag with this block inside it, and this block is count.get.toString. And what happens when you, what the view macro does is it actually creates these effects for you. It creates the DOM nodes, and then it creates these effects for these targeted updates. So it's basically wrapping this same function in an effect to say whenever this needs to rerun, just set the text content of this one thing. It actually is working with a text node there, not the text content of the element, but that doesn't really matter. But so this reactive system is exactly almost what the output of the view macro looks like, but we're going to do the whole thing just in vanilla for ourselves. Cool. Okay, so then let's start fleshing some of this stuff out. So we create a signal, and it's returning a signal, but we don't have an actual signal type yet. So let's define that. So it's going to be a struct signal t. We're going to derive copy and clone on it because this is one of the really useful characteristics of signals in Leptos. They are a copy type. You can just move them into and out of closures. You can do whatever you want with them, throw them out. It doesn't matter. They're just a stable reference into the reactive system. So the type that this needs to take is it's going to take a static reference to the runtime, right? Which is why I leaked that instead of doing something like an RC, right? Because this is copy. So now we can just do exactly that same thing. It's just copying this reference to that runtime object. And this isn't a memory leak per se when we leak it, right? Because we're just doing this once ever. So it's just a single allocation up front. It's not leaking it by running over and over or something, right? Okay. And then it's going to take an ID, which is, we're going to call a signal ID. And that signal ID is a type that we'll talk about a little bit. We haven't defined it yet, of course. So let's define it right here. This is going to define a bunch of traits, but it's just going to be a wrapper around like usize, right? We'll talk about that in a second. And now it's going to complain at me, right? Because I want this signal to be typed. I want it to have a type T that indicates the type of the signal. Like I want this to be a signal I32, right? So all that we need to do is just tell Rust that by saying this is a phantom data T field. This only exists basically at compile time. It's to be able to type this thing when neither the signal ID nor the runtime has that generic type, and it will just disappear. It doesn't add any cost to the structure. Okay, so now we've got our signal ID, but how do we actually make this thing happen? How do we create a signal? So kind of the key here is that all of the signals that you're using and all of the effects are just indexes into some point in the reactive system. For a copy type to be useful, you kind of need it to, one, be very small in memory, so it's very cheap to copy, right? But copying it needs to preserve the same exact meaning, in a sense. So like if we just had I've used this example in the stream I did with Ryan Carniato, but if we were just doing like let mute count equals 0, right? This is a copy type. We could do, count plus equals 1. We could do, oops, I keep getting these backwards. Count minus equals 1. We could do count plus equals 1. But because this is just a plain copy type, like this will copy 0 into one place and 0 into the other place such that it's almost like you're doing this. But 0 doesn't refer to the same 0, if that makes sense. So now when you click these buttons, you're actually changing two different states. Like each one works within its event listener, but you have these stale closures where it's no longer updating this variable that exists on the outside, it's copying it in. So instead, we want some kind of copy type that is a stable reference. And so we're going to make this type that's a reference into the single runtime system that we share. And that's where kind of the shared state lives in this runtime. And the way that we're going to do that is with a really simple form of arena allocation. It's not even really arena allocation, but it's like it. And you would never do this in a real system. This isn't what Leptos actually does. We use a crate called slot map, which is definitely the go-to. But you'll just see how this works and bear with me for a second. So let's call this signal values. We're only ever going to have an immutable reference to this thing. So we're going to wrap pretty much everything in a ref cell. And then let's just say this is a vec, and let's see. This is a vec of all the values of all the signals, right? That's signals of any type. So let's go up here just to make the types a little less messy. Let's say signal value, and that's going to be box, ref cell, din any. And the reason it has this type, right? Din any tells Rust, this could be any type, and I'm going to downcast it to the correct type at runtime. Ref cell says I need to be able to mutate this thing, right? Because we need to be able to change the value of that signal. And it's boxed because it's a trait object. So we just have this, vector of signal values, right? So what do? Well, it gives us a value, and we go into signal values, borrow mute, and we push. And then we box new, ref cell, new value. And then how do we get the ID? Well, the ID is just an index in this vector where this value can be found. So we know this value will always live at 0. This is the first one we're pushing in. So the ID is just going to be signal ID, self.signalvalues.borrow.len -1, right? Like it's just the last thing we pushed in. And that's really all we need, right? Now we can return a signal. CX is going to be self, right? It's this runtime. And this is why we take a static reference to self up here. ID is just going to be the ID, and the type is just a phantom data. And we've just created a signal and apparently added an extra. Why is that? Did I put an extra bracket or something? Yeah, whatever. We're just going to inline it in there. It doesn't matter. Okay, so now we've got create signal, but we don't have get and we don't have set. And of course, create effect doesn't do anything. So let's work on the getter and the setter first. So we're going to go into this signal type. And get should just take a reference to self, and it should return t. And set should take a reference to self and a value, and return nothing. All right, and so what do we need to do? We need to get the value. We have the ID, right, stored in here, and we have the runtime. So we need to go into the runtime, into signal values, and get the value that's at that ID. I'm going to do this in a couple different steps, partly for clarity and partly because with ref cell stuff, Rust is going to complain at me if I don't store some of these intermediate steps. All right, so let's say self.cx, the runtime, .signal values, .borrow, and then we're going to index into that with self.id.0. It's that usize we're storing in there, right? So now we've got a boxed ref cell din any. We're getting there. So let's say value equals value.borrow, right? It's inside that ref cell. So now we've got just a ref din any. And then the way that you get the actual type is downcast ref, and we specify the type. And this can be any type, right, we're saying. So it's going to give us an option because maybe there's a type T there or maybe not. We stored it there. We know it's there. We're just going to unwrap. And then this gives us a reference to T. And for the sake of simplicity, we're just going to clone. In regular Leptos, there is instead this with function, right? Where instead of cloning the value, I can run this closure against the value, so I don't need to clone it. Let's just keep things simple, right? And we're actually going to say it's static 2 because that's important for the any stuff. It has to be a static type. Okay, so now we're getting it, right? Cool. And then for setting it, let's call this wrapper, and we're going to do the same exact thing. Right, index in here, except for the wrapper, we're going to do wrapper.borrowMute, right, because we want to mutate the thing. And then we've got this mutable reference to it, and we need to downcast it again to the proper type. Value.downcast, wrapper.downcast mute t. We still know that it's the right T because we put it there. And cool, so now we've got a mutable reference to T, and super easy, we just wrapper equals value, right? So that sets the value. Let's add a few comments for later. Okay, so now we've got a set value, we've got a get value. We've got a set function and a get function, rather. I need to add the same bounds on here, that's fine. And we are missing, let's see, these, it wants me to put references, and that's all fine. This is just, reading what Rust Analyzer gives you back, right? Okay, but so this create effect does nothing. So the reactive system, right, consists of two halves, which are signals and effects. Signals are values that change over time. Effects are functions that run in reaction to those changes. So you need to know, well, when do I need to rerun this effect? And the answer is, I need to rerun an effect whenever a signal is set that I know the effect depends on. Okay, so how do I know that the effect depends on this signal? So you go down into create effect, right? And if you see, oh, and by the way, I'm now getting a bunch of errors right here because I just need to put move on all of these so that they are static lifetimes, right? But because it's count that needs to move in, and we have implemented copy on this signal, it's going to just move those all in really easily. All right, so how do we know that this effect depends on this signal? If you look in the body of the effect, right, you have this create effect, set text content, count.get.toString. So somehow, when we do count.get, it needs to tell this effect that you depend on count, right? So it would be great if we had some way of knowing whether there's an effect that's running at the moment. So let's just do that, right? So let's say running effect, go up into our runtime, and this is just going to be a cell option, say effect ID, just like we have a signal ID. We don't have an effect ID type yet, but let's just make one, just a copy paste, right? Cool. So running effect, and then what do we want to do, right? So like we said, if you are getting a signal inside an effect, it needs to somehow notify that effect, or it needs to register itself in some sense. All right, so add subscribers. If let sum running effect equals context.runningEffect.get, right? What do we do? Well, maybe we need some kind of list of subscribers, right? Let's go back up into our runtime. Everything is going to live in the runtime. This is why the signals are so cheap, because they don't have to maintain any of their own state. They just need to know who they are, and the runtime will do the rest. So let's call it signal subscribers. And what does this need to be? So we basically want to map between signal IDs and like a hash set, like a set of effect IDs, because we want to know for any given signal which effects depend on it. So let's do that. Let's do a ref cell. Again, using a hash map is not actually the best way to do this. If you want to look at the internals of Leptos, we're using slot map and a secondary map, right? Whatever. Hash map is going to work fine for us, the way we're doing it right here. So it's just a hash map between a signal ID, and then this is going to be, a hash set of effect IDs. This should be fine. So if there's some running effect, let's see, we want to add a subscriber. So we want to do like subs equals self.cx.signal subscribers dot, and here we're going to do, take a mutable reference to it, and then we're going to do subs.entry self.id or default. And what that does, right, is if you're not familiar with it, the hash map APIs here, this checks if there's already an entry in the map for this signal ID, and if not, it creates one, and it's just going to be this or default, which is going to be an empty hash set. And let's see, I think Rust Analyzer is unhappy with me about something, and that is fine. Oh, I think I haven't imported hash set, fine. Subs.entry. Subs needs to be mutable. Good, it should be. I've got this borrow mute. I'm going to mark this. Okay, right? So now we've got this mutable hash set of subs. And all that we want to do is basically subs.insert this effect ID, right? Running effect. So that should be pretty simple, right? When we call get now inside this effect, it's going to say, is there a running effect? It's going to check, okay, it's running inside this effect. Then it's going to go, it's going to add this effect as a subscriber. Okay, except that when we do create effect, we don't actually set the running effect, right? So let's go in here and let's actually create the effect. So we're going to do the same thing, like we have signal values. We probably want another thing that we're going to call effects. And this should just be a ref cell of probably a vector of, I don't know, boxed in function, right? We're just going to stash the functions in there, and we're going to get these function IDs. So we do the same exact thing, self.effects.borrowMute.push box new f, and then let ID equals effect ID, self.effects borrow len -1. Cool, so now we've got this effect ID. And now what we want to do is run the effect. So let's actually create a separate thing that we're calling run effect, and it takes an effect ID. And the reason we want to do this separately is we want to be able to run an effect over and over. So we want to be kind of separate from the create effect. We do need to run an effect immediately when we create it, because it needs to immediately run so that it can have its effect, right, and get its subscribers. Okay. So run effect is going to say something like, let's run the effect. So let's say let effect equals self.effects.borrow, effect ID.0, right? So we're just pulling that function back out of the reactive system. And then let's just call it. And let's see if anything happens. I'm seeing I'm getting, this is just ID. I'm seeing I'm getting one error here at, that can't be right, line 12. Create signal T. Isn't that right? Oh, wow, I'm way behind in my, there we go, okay. Okay, look, so now we actually see, right, the effect has run once, right? So you see, when we set the initial value, it says not reactive yet. When we create the effect, now we're immediately running the effect. So it does set the text content, and we do have count.get works. It gives us 0, converts it to a string, and here we go. Okay, so now when we press the buttons, what happens? Absolutely nothing. You still see the logging, the buttons are working, but it's not updating. The reason it's not updating, it is actually updating the value of the signal, and the get is actually subscribing, but if you'll notice, there are two things that we didn't do. One, when we set the value, we didn't do anything to notify those subscribers. And two, when we run the effect, we never actually set runtime.running effect, right? So this is checking when you get it, is there a running effect? And the answer is always no, because this is just a cell that contains none. So instead, when we run an effect, let's set that running effect. And you can think of it like a stack, right? So like there are often nested effects because of the way that your application is built up of a bunch of components running inside components, and things rendering stuff using effects. So it's almost like a stack. So we're going to say previous running effect, and we're going to do self.running effect, running effect.take. So it's going to take whatever was previously there, which maybe is none, maybe is some. Then it's just going to say self.running effect.set some effect ID, because we know which effect we're running, right? And then we actually run the effect. So we can call this like push effect onto stack, run the effect, pop effect off stack. And to do that, right, we're just going to set running effect back to previous running effect, right? Whatever it was beforehand. Okay, so now at least we are getting, this subscription, because when we call get now, when we run the effect, right, the first time, count.get will be called. Count.get is going to check if there's a running effect. There will be now, so it will add this subscription, but it still won't do anything because we're missing the last piece, which is when you actually set something, notifying subscribers. Okay, so here we get into a little bit of stuff that sometimes causes me bugs that you don't have to worry about, but that has to do with ref cells and overlapping mutable borrows. So if there's anything that's a little bit rocky in the next couple of minutes, sorry about that. But what we need to do, right, is basically get that set of subscribers to this signal. We know which signal we're in. We know that it has some subscribers. So let's go, right? So we're going to say if let sum subs equals context.signal subscribers dot borrow dot get self.id. Okay, and I see I've shot myself in the foot with this several times already. We actually need to do this in a slightly different way. So we're going to say let subs equals self.signal subscribers borrow dot get. Take a reference to self.id. And then we're actually going to clone this hash map. And the reason is we just want to pull out the existing set of effect IDs, because underneath here, we're going to rerun all of those. And when they rerun, they're going to want to mutate this set of subscribers, because basically, so we set this signal, right? Setting the signal will cause the effect to rerun. Rerunning the effect will get the signal again, And getting the signal is going to want to mutate that set of subscribers. So I'm actually just taking this immutable borrow, cloning this pre-existing set of subscribers, and going about my business, right? So if let sum subs equals subs for sub in subs, this is subscriptions, right? And then we're just going to do run effect this sub and see what happens here. So, yep, great, fine. So this is just one of these intermediate value things with a ref cell that it just wants me to assign into a variable, and I've named it wrong. So it just wants to store this ref inside a variable before I do other work with it. Subs may not live long enough. Subs dropped while still borrowed at 78. See, this is the thing that kind of kills me. This should be maybe cloned. Yeah, okay. Like the difference between cloning an option with a reference into the hash set and doing cloned means it's cloned is cloning the hash set, and clone was cloning the option with the reference, whatever. Run effect, good, and now this is just the effect ID instead of the reference to it. Cool, so this should be good. And now let's go back in here, and there's a chance this panics, but yeah. So what's mad at us here? Already mutably borrowed at 53. Great, so the problem is that signal values is immutably borrowed here in get, and it's being, let's see, this wrapper is immutably borrowed in the get, right, this value, and it's being mutably borrowed here. And this is, I actually think, as simple as wrapping this in its own scope before we rerun the effect, because otherwise this borrow mute would be held onto until the end of the set function. We actually only need to hold onto it during this assignment. Wrapping it in braces, right, in Rust makes all these variables go out of scope. It releases this borrow mute. Yeah, cool, okay. All right, so if we refresh now, you'll see -1, -1, -1, and then +1. This goes back up to -6, right? So it's obvious that they are sharing that value. It is not a case where we've just copied two separate mutable things into closures and now we're mutating these two independent variables. It actually is some shared state in that runtime. And the buttons just work, right? So what was that? That's not bad. That's 131 lines, right? And we've just implemented a basic fine-grained reactive system to drive some web UI rendering. So let's walk through how it actually works. And I'm going to just do one more thing to make it a little more interesting. Let's create another thing, another element that we'll call double. And let's start with double count here. And then let's create another effect. And that's going to update. And then let's make something, right? Let double count. So double count is now a derived signal, right? It's just a closure that accesses a signal and does some work with it. And you can see in the types, like count is a signal, double count is just an ordinary closure. So in this one, we're going to just call double count and see what happens. Because I already moved P into this, and what I actually want to be doing, and this is where the seemingly irrelevant errors can actually save you from screwing stuff up, right? What I actually want to be doing is setting the text content on the double paragraph, not the regular one. And I did not actually append it. Cool. All right, so now I've got these two paragraphs, they're both at 0. And when we click +1, you're updating with the double count. Now, importantly, right, this is being driven by one signal and two effects. Double count is not a signal in the in the sense of this runtime system, right? It's a derived signal, we call it. It's a closure that accesses signals, but it does not get pushed into this reactive system anywhere, right? It's not, you're not doing create signal. It's not being pushed in here. What's actually happening, right, is you're now accessing this same count signal in multiple different places. So you're creating an effect here. When you call it here, count.get, okay, it adds effect 0 into its dependencies, into its subscribers. Now we're creating a separate effect, which is updating a different thing, and we're calling double count. And when you call double count, calling double count calls count.get, and because you're inside this effect, like being inside the effect is in terms of the execution, right, not spatially or visually or something, you're still inside this second effect. So it also adds effect, it added effect 0. It's now adding effect 1 into its subscribers. So you've got this one signal inside the runtime. And now when you set that signal, it says, okay, great, set the signal. So we actually set the value inside the system. We get out our subscribers, which is now effect 1 and effect 2, or effect 0 and effect 1. And then for each of those subscribers, it reruns it. So now this one signal is independently, via this derived signal, updating two different effects. And of course, we don't need to use a derived signal, right? It can just do it by itself. And because it's a copy type, right, this count, we are, now they're just the same thing, right? This count, we can move into this create effect, move into this second create effect, move into this event listener, and move into this other event listener. And every time we move it, all that it's doing is copying this reference to the runtime, this signal ID, and this doesn't even exist. So it's just copying these two things. That's what, like 8 bytes or something. And that's all. And so we can copy these things, we can move them around, we can throw them away. They're just an index into this one stable runtime system. And the runtime system, it's decentralized. There's not like an event loop in this runtime system that's going through and checking values or something. It's just a centralized storage. And then each of the signals and each of the effects kind of manages its own need to rerun or need to update its subscribers by using these stable IDs into that reactive system. So this is how we have managed to have such a nice developer experience, right, with being able to just copy and move this signal type everywhere, because it's just a static reference into the runtime system. And this leak, by the way, this is not a memory leak in a traditional sense. We're leaking one structure one time. So it's just like one static allocation when you're running the program. This will be reclaimed by the browser when you navigate away when you're in WebAssembly, right? And it's not happening over and over and over and over. So it's not leaking over time. It's just taking this, placing it outside into a static lifetime. But yeah, so I mean, this is the way that the entire rendering system works. Like the entire rendering system is built on creating effects that wrap the smallest possible change to something. So for example, if I created something with the view macro, like I would do in Leptos, and say I just had like a paragraph ID equals double count. This is silly. And then the text equals count.get. So it's just wrapping each one of these things in a separate effect, right? So it's creating an effect that says, create effect P. This is basically create effect P.set attribute ID to double count .toString, probably a reference here. And then it's creating a second effect that does basically this, right? Setting the text content to be count.get.toString. So you now understand, right, when you're using the view macro, exactly how these targeted updates work. It's just wrapping those closures in effects that know that they only need to rerun exactly when the signal that they depend on is actually set, and they run totally independently of each other, so that you can make these super targeted fine-grained updates to your user interface that reflect these fine-grained updates to the signals that compose this reactive system. And it all becomes really, really composable and really easy to use, because you can do things like this derived signal, and as long as you have that one runtime in the actual framework, it's just like a thread local runtime in the browser. As long as you have that one thing, all of these signals and effects can coordinate with one another without you having to do any of the work to do that. So yeah, that was hopefully pretty comprehensible, a little bit in the weeds for an intro video, but I wanted to start with something people have been asking about. And I hope that this makes it easier for you to understand how the fine-grained reactivity works, how effects understand when they need to rerun, how signals tell effects to rerun when they need to, and also a little bit about how the memory stuff works, why these are copy types, why it's so easy to use. And hopefully I hope this makes it easier for you to write applications and write great code and go about your day building really cool stuff for the web. So thank you so much, and I hope to see you all soon.